was your Viva? Huh? Bad. You're not able to answer, right? Huh? Shy to speak. But you'll have to speak sometime, right? Which were the questions? Like you were knowing the answers? Were you knowing the answers? Were you knowing the answers? Which were the questions which were asked? Huh? What was the question? Ah. Ah. XOR was there or OR was there? XOR was there. Oh. But anyway, you could have, that means like this you are saying? Like this? Okay, okay. But you could have analyzed, no, this one? Okay, what else was asked? Only this question? Ah, 2's complement. Why you were not able to answer? That 2's complement. What is the limit here? That is what was asked. 2's complement. 8-bit 2's complement number. What is minimum and maximum number? 4-bit. So 4-bit, how much it would be? 4-bit, it's like 4-bit, no? So it's like, let's say these are the bits. This bit is like mostly for the sign purpose, just because it's a 2's complement form. Always remember that the limit, lowest limit and the highest limit is from 2 to the power n negative 2 to the power n minus 1 to the power n minus 1 minus 1. So this will always be the limit. So what is the range of this? It will be like from minus 7 to 8. No, sorry, minus 8 to 7, no? How much it is? Yes, minus 8 to 7. Always. Just because that, see, what is the lowest number which we can represent? 0, 0, 0, 0. But this bit is like, when we say that it is 0, when there is no carry, I mean this is the carry bit, when it is no carry, then we say it as in, the answer is in 2's complement form. And it is negative, so it is minus 2's complement is like, no, it will be like from minus 111, yeah, it should be from minus 111 to 111. But you know, there is a 0, minus 0 and plus 0 is also included here. So they are not two zeros. So 1 0 we include on the negative side. So that's how we get this range. Always remember the range is from minus 2 to the power n to power n minus 1. Alright, we'll go for this coding. We have seen shift registers, no? Last time we have seen shift registers. So were you able to do the shift register? Huh? You didn't bring laptop? You don't have it. Achha, achha. Then how do you perform? In? Achha, achha. Okay. Fine. So what we can do is, you have mobile phone. Mobile phone, it will be difficult. Then it will be very difficult. Wasn't working on phone? Alright, what I will do is I will take some theoretical part. There was TTL CMOS question for you. TTL CMOS, did you ask that question? TTL and CMOS. They asked. What did you answer? Answer anything. actually the thing is like all the ICs that we have, these ICs are having some limit. There was one more question which was asked. Let's discuss the questions again. The question was like, you are having an AND gate, and one input of this is given to a sinusoid of 5 volts. This was asked to you. Were you able to answer? Huh. 50% of this. So it will be, output will be what? Yeah, I mean that's true, because see, when it reaches like the minimum value of, because it, see, this portion is like how much minimum it should have like considered as 0, or see, for any IC there is a limit. I mean when we say logic 0, it is from what range? From 0 volts to, let's say, from 1 volt or 2 volts, that is logic 0. And logic 1 is like 5 volts is the maximum, but you know, it depends on, let's say if it is 4.9, then also it is logic 1. So what is the lower limit of that? So it may be 4 volts to 5 volts, something like that. So actually that is called as a noise margin. I mean if we have this one, I think, right? So that is what they have asked, because the lower limit, what is this said? This is the, now, okay, what I will do is, usually the input signals we expect it to be noisy. I mean the typical input and output logic levels are something like this. Like, say for example, I am just drawing its representation. So say we have this one. See, what I am drawing is, here let's say this is 5 volts. I am just drawing the logical representation. This is 5 volts, this is 0 volts, and let's say this is some value. Okay, so I'll say that this for the input and these are for the outputs. Usually this output ranges or the levels are usually higher than the input levels, just because we consider the, see, the inputs may be, output is a part of a circuitry or electronic circuit, like it is having some preciseness. So it is like as much tight as possible. So it is as close as to 5 and it is as close as to 0. But that is not true with the input. So input may be deteriorated. So input may be ranging from 0 volts to some value. So the maximum value which can be considered as input low, so that is called as a V. Now this input, no, VIH. That means what? This is a maximum or the highest level which can be considered as low. I mean that is what it is, VIH. And this is what is called as the maximum input, VOH, or sorry, no, VI. So this is low levels, so VIL, and which is VIH. What is this? VIL is nothing but the maximum level. Let's say it may be 1 volt or 2 volts or 3 volts. That can be considered as logic 0. So it may be like, that is from 0 volts to VIL, we can consider it as logic 0. And from VIH to 5 volts, we can consider it as logic 1. So in that sense. So the minimum value for which the the input voltage can be considered as high, that is called as VIH, and the maximum value, so it's like other way around, so let me write that. So VIL is nothing but the minimum value, minimum voltage of input which can be considered, oh sorry, not minimum, it's maximum, right? So it's maximum. So maximum voltage of the input which can be considered as logic 0. Similarly, VIH is nothing but the, now what is that? It should be minimum, right? So it is minimum voltage for input to be considered as logic 1. No, that is indeterministic state. That is indeterministic state. I mean, it will be like a hanging state. I mean, it is not 0 or not, neither 0 or neither 1. Similarly, we have for the output, right? For the output also we, now I should give another notations here. So it's like VOH, right? And here it is VIH. So what is VIH, you tell me? Not VIH, VOL. VOL and VOH. So what is VOL? This is the maximum input voltage which can be considered as low for the output. Maximum output voltage which can be considered as low. This is what the minimum output voltage which can be considered as logic high or 1. So either way is fine. So this one, okay, this is NML. So this one, okay, the difference between VOH and VIH is called as a noise margin for high, NMH, and this one is called as a noise margin low. What do we expect? What do we expect, and what should be the ideal condition? Noise margin must be 0, is it? What should be the ideal condition, you tell me? हाँ, उसका उल्टा. See, we should take care that okay, सबसे कम वोल्टेज भी इनपुट में डिटेक्ट होना चाहिए, that is as logic 0, but उसको कुछ लिमिट होना चाहिए, threshold. What is the ideal limit for that? No, limit, maximum input voltage that can be considered as low. So half of this, that is what the ideal situation is. So half will be considered as low and half would be considered as high. And what is the ideal output? This is what the ideal input should be. I mean, ideal input should not bother about, it should be like, no, 2.5 volt से थोड़ा कम भी रहा तो that should be considered as logic 0. 2.5 volt से थोड़ा ज़्यादा भी रहा, that should be considered as logic 1. What should be about the output? Now output, it should not be, because it's like circuit ka output, no? That should be as ideal as possible. What is the ideal situation for the output then? Logic 0 is, yeah, complete 0, it should be like logic 0, and complete 5 volts should be logic 1. That means this noise margin should be as high as possible. So noise margin is nothing but an average of both of them. So that should be as high as possible. This is what is called as a noise margin. I think same was the question which was asked. What is noise margin? I mean, the question yesterday, we are just discussing what kind of questions were asked yesterday. So this noise margin is nothing but the ability or the margin, or you can say the precision or the allowed number of range, so as to consider or allowed the voltage level which can be considered as low or high. So So ideally it should be as high as possible. That is called as noise margin. And this is what one of the specifications you would find in any data sheet. So noise margin, it may be considered as NMH plus NML, and usually they take it as average, both of them. So this is one of the specifications of the IC. What was the next question which was asked? Do you remember what kind of questions were asked? Yeah. So that is what I was. That was the question which was like very easy. See, another question was like, so this Viva question 2. It was asked to design this 2:4:6 and back to 6. This is what the counter was, right? 0 was also there. 0, 2, 4, 6. That was the counter. So if I see this 0, 0, okay, 0, 1, 0, and this was like 1, 0, 0 and 1, 1, 0, right? So this was the counter which we wanted to design. And what is the usual procedure? What we see, we look at the highest state. What is that? 6. So to represent 6 in binary, we require like 3 bits. But that's not true. I mean, see the pattern in which this is appearing. I mean, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0. One bit is always constant. So we can keep that, simply make it ground. So I think after half of the Viva was done, many people were able to answer that, just because maybe they have discussed with the others. So if we consider this LSB as constantly 0, I think 2 flip-flops are okay. Okay, so simply we need to make those flip-flops to count from, just from, oh, not here, it should be 1 here, no? Just to count from 0 to 3, that's it. 0, 0, 0, 1, 1, 0, 1, 1, that's it. And this we can simply ground. We can consider one terminal as ground. So the complete circuit would be something like this. Now this is an up counter, right? So what I would do is, I could simply up counter. Now I am having choice that I can go for synchronous or asynchronous. So I am just going for a simple ripple counter. So I would require 2 flip-flops. The LSB here, I mean, this one is the LSB, right? So ye wala LSB. Okay, just because we are using only 2 flip-flops. So let me name this. So this will be bit 2, bit 1 and bit 0, and the connections would be like this. That's it. I mean, yeah, the toggle thing is also required. I will connect this to, tell me, 1. This toggle, and this is what a clock is. Now this may be positive edge triggered or negative edge triggered. I mean, I'm drawing it as, now we want up now, so I will go for the negatives. So this is clock. Q, and the output is taken from here. And 1 is like the third one. I can simply consider, which one is this terminal, you tell me? B2 है या B1 है या B0 ये टर्मिनल बोलो. This one. Which bit is this? Huh? Which among these, which one? B1, not B0, because that is ground, so that can be considered as B1. This is considered as B, B2, B2, and the third bit you can simply consider as ground. That's it. This was all about how you can design an even counter or an odd counter using only 2 flip-flops. So what was another question? You tell me. So this is ground. So this becomes, you can count up to 6 using only 2 flip-flops. Okay. Next. What was the question? Viva question. और क्या क्या पूछा था? मतलब I was like very surprised. Surprise नहीं बोलेंगे, shock बोलेंगे. मतलब लोगों को आए नहीं बहुत सारे questions. मतलब आपको पता था या फिर रिवीजन नहीं की होंगी. बताओ और कौन से questions थे ऐसे? Questions you were not able to answer confidently. That's it. We have just discussed that. See, 2s complement is like if any number is there in 2s complement form. Say for example 8 bits. So we are having 8 such bits. And we say that we need to represent that in 2s complement form. In 2s complement we have to take care of positive and negative also. And the question was, what is the maximum and the minimum number we can represent using n bit 2s complement number. So what we can say is this last bit is sign bit, so just discard it. I mean that can be 0 or 1. So with that as 0, what do we consider when the sign bit is 0? See, when there is no carry, the answer is in negative, right? In 2s complement form. That is what we consider. So what is the maximum number that we can get? All ones. I mean negative in in 2s complement form, maximum number we can get is all ones. That means minus of 127. That is what we can get. I mean it's 7 bit, right? Or minus of 127. Yeah, that's true. Minus of 120. That is 7 bit 2 to the power 7. Okay, is that okay? And same thing we can get it for positive also. It is plus 127. But have you seen that there is 0 also involved? So minus 0 and plus 0, which doesn't mean anything. I mean minus 0 also we can consider, plus 0 also we can consider. But there is no need to consider 0 in both the sides. So we can consider 0 only in the in the negative side, you can say. So in that sense, the range will be from in the positive side. So I mean you can consider in the positive side or negative side. Usually what they do is they consider that in the positive side. So it's like ranging from minus 128 to 127. That is what the range is. I mean you are getting what I am saying is, if we consider the MSB as a sign bit, so that can be 0 or 1. For 0 and 1 we are having range from minus 127 to 127, minus 0 to minus 127 and plus 0 to plus 127. Is that okay? But 0 is considered in both ways. That is not, I mean that doesn't mean anything. That is actually illogical. So we should be able to, I mean we can consider 0 only at one side, I mean either in the negative side or in the positive side. In that sense we can count one more digit. So the range would be from minus 128 to 127. So that minus 1, I mean in general it would be from 2 to the power minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus, that is what it would be. Alright, so this is what the range was for the 2s complement. Any other question? Okay. You were able to, yeah, there was a question saying that which kind of IC was it? I mean, was it a TTL CMOS? See, I understand that we haven't covered that TTL and CMOS thing just because I wanted to cover more towards like, see, I focused more on competitive exams, and TTL is something like 50 years back it was like nice, and now we are using CMOS. So this is like a different implementation in which the IC logics are built. Say for example, now I need to implement some logic, okay, some logic. Can you tell me which logic is this? I am having a transistor, some kind of arrangements, something like this I am doing. So I am having lag here. And I am considering this as ground. Let's say it is input 1 and input 2. Do you remember transistor? First you tell me, we have seen that in last semester. What if the input is high, what is the output? I mean, suppose the input is like growing, something like this. The input, this one, input 1. Suppose it's something like this. What is the output here, you tell me? Do you remember? What kind of configuration is this, you tell me? Common emitter. Yes, it will be 180-degree phase shift. So as you go on increasing this, that means if it is logic 1, it will be 0 there, and so on. So if you consider like giving 0, it will be logic 1. Why? Suppose if it is 0, IB will be 0. If IB is 0, IC will be 0. If IC is 0, there will be no current flowing. And what is the voltage here? It will be 1. So if the input is 0, it will be 1 here. As good as 5 volts. What is here? Same thing, right? If it is 0, it is 1 here. Now, what if 1 is there? Input will, what is the output? It will be 0. Okay? It will be 0. But that 0 is, say for example, if 1 input, now I am making this variation. What if 1 input is 0 and the other input is 1, it will be 0 here. What is the output here? Now see, it is getting this 1 voltage is again grounded. So what is the output? Now let's form a table. If it is input 1, input 2. What if both of them are 0? You tell me. Output is 1, 1. And this is acting as a like a AND. I mean 5 volts are just simply connected to each other. So what is the output is 5 volts, as good as high. What if the input is 0, 1? I mean this input, okay, the other round is 0, 1. Is that okay? What if it is 0, 1? here it will be 0 and this will be at VCC, but as it is ground, the current will flow from this, the output it will be 0. So this wire is acting as a AND kind of problem, AND kind of situation here. So output will be same situation for 0 1. What if it is 1 1? What if it is 1 1? 1 1 के लिए भी what kind of gate this is? Huh? Huh? What kind of gate this is? NOR. So we can implement the NOR using 2 transistors. So in this fashion we can implement any logic. So you remember I have asked you some question someday, like okay, this is what is this? Okay, toggle flip flop. What is there inside this? Or a D flip flop you can say. What is there inside this? 2 latches. 2 latches. One is master and one is slave. You remember this? This clock. Okay, D. What is there inside this? Gates. Okay, NAND gates. Okay, OR gates, NOR gates and so on. Or NOR gates. What is there inside this? This is. Now you got it? And what is there inside this? You know it, right? How the transistors are like manufactured. We have seen that in analog electronics. Now you are at and what is there inside that we all know. Electrons, protons. Like now we have gone through like very basic level of from hierarchy. Now you have got the abstraction. Very first day I have shown you like a levels of abstraction. Do you remember that? Levels of abstraction we have seen that, and what levels we would be focusing on. That is what we have seen. Like it was. Let me show that to you. Not here, but I think if I am having slides. Yeah, it was there in presentation. You remember this slide shown? What is there inside it? And now, like as we are at the, do you remember this? What is there inside the IC? This one. What is there inside this? Gates. What is there inside this? The CMOS. Now this is the CMOS implementation. So that is what the question was. How, which kind of implementation you are using? Is it a CMOS implementation or a TTL implementation? We have seen this, right? And this is what I have told you, that what are the levels which we will be focusing on. So transistors we have already seen, and we are now seeing logic gates, register level, and microarchitecture implementation. Like microarchitecture will be like ALU design and so on. There was one project presentation, I think by Vedey and all. So they have presented a small ALU, like addition, subtraction, logical operation. So that can be considered just above this level. So this is like, and above that it will be like, now say for example you need to program something, program some ICs, like you have built some IC and you need to program it. How will you program it? Like what are the instructions to be said? I will have to give some controlling operation, like when I want to copy, when I want to add, when I want to subtract. So that can be, instructions can be given with a set of instructions set. That you will be learning in the next semester. You will be having microprocessors. There you will have to insert the opcodes. Let's say for 0AH, that will be mostly in hexadecimal. That will indicate what kind of operations to be performed. So it's like, above the micro architecture is like instruction sets. But it's like very difficult to insert this every instruction in the hex format. So it's like higher to that is a C language or an embedded C language, which we have done in the workshop. If you remember, we are having embedded C language. What that embedded C language would do, it will actually compile the program and it will convert that into the machine level language. Instruction set will be converted into binary and then it will be how it will be programmed. Above that, अब program जो हम जो compiler use करते हैं वो किस में installed है? Operating system. And operating system किससे बनी है? So that is how the hierarchy is. You will be able to now by the end of 4 years program, you are the computer science students. You should be able to have a clear idea how the operating systems are actually designed. You should be able to design your small windows like छोटा सा operating system. So that is how you should aim for. Okay. So this was just all right. So you got I haven't still I didn't answer the question yet. So the question was which kind of ICs that you are using. So usually this 74 series.
4 series are usually the CMOS series. Okay, so based on the determine which kind of implementation it will be. And you have gone through various the data sheets. You should be able to answer that. You didn't ask me such questions, so I didn't answer. You should be able to curious enough to ask what is LS. So LS is what is called as a low power short. Schottky सुना हुआ है? Schottky diode. So Schottky diode is actually preventing. So let me write that low Schottky. So this Schottky diode is nothing but it is used for transistors to avoid the saturation condition. That in that sense it will be like it will never allow this transistor to go into the saturation. Like the transistors would operate below saturation levels. So we'll see the structures. I'm just covering the questions first. Just because हुआ क्या कि वो हमने cover नहीं किया था और वही पूछे गए. Just because ये हमने last portion रखा था. जैसे this is more like a theory part and also I just wanted to avoid and I wanted to focus more towards programming and towards the competitive exams. So this we'll cover in the next 1 week. So this week will be like our last week. Okay. After that we'll be finishing the course. This week or maybe we may take 1 or more lectures. So before, when is your exam? 24th, right? Next to next, no? So next week, by the end of next week, we should be able to finish this. Any other questions? You got this answer? Like from the series, you can determine. What else? Yeah. What is? NE. NE is it may be the series number from the manufacturer. There are various series numbers. What else? That's what you were able to answer. Other questions also? I think the Viva questions were not difficult, but still people were not able to answer. I don't know why. I simply asked the question like, no, how many, let's say for example it is 6, how many flip-flops are required to just implement this counter, which will remain in 6? So the answer is no flip-flop is actually required. Okay, so we'll go for this Verilog coding quickly. In Verilog, now in this we have seen, last time we have seen the shift register, but using shift, right? So it should be what? X, 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 followed by 1, 1, X, X, and so on. You got it? This should be the output. But without using the inbuilt, what is that? Inbuilt reg Okay, without using inbuilt reg, without storing anything, you have to go for this. Okay, using structural design. That means what? First you implement D flip flop and use that as an instance for the next module. I'll show you. So what I'm showing is, so something like this. So I'm using the D flip flop module, and then we are simply making it as an instance and then reusing it. Okay, so go for this coding. So the first thing is to define D flip flop. That you can very well do that and then use that as an instance. Once you are done with that, okay, the next job is this one. Okay, I want you to this operation. Say for example, I am having two resistors. Four bit. I want you to copy. Now this is what happens while serial communication, like in USB communication or in LAN. So this is A and B resistor, both are 4-bit registers. Assume that there are some values in these resistors. Let the values be 1100 and 1010. After 4 clock cycles, I want this to be copied here, complete thing. So this B should also have 1100. That is what I want. Do it in Verilog. You got it? The problem you got it? And what should be the rest of this? Rest of the values here? You may retain the values or you may make them as zeros. Okay. See, we have seen how to implement that shift registers, right? Shift registers कैसे implement किया था पिछली बार हमने? Using the concatenation operations, right? Concatenation हमने use किया था, ये वाला use किया था क्या हमने operator? You didn't use this? Then what have we used for shift register? Shift register serial in serial out हमने लिया हुआ है पिछली बार. क्या use किया था हमने? How did we implement? Okay. So we have used this using like Q of 0, something like that. This is what we have used as I. That is what we have used, right? So there are various ways to implement this. Okay, so let me do this.